everyone, I'm Caitlin Greenberg and I'll be showing you today is how to create a mobile. First things first, we are working with spectrum glass. I've got 3 different colors here that we'll be working with, and we'll be putting them into the kiln and manipulating them by fusing them together and then later slumping them to change their shape. So we're going to first start off with cutting. Very important, our PPE. We may need to make sure that we have safety glasses on so that any shards of glass that break do not go into our eyes. Also, what's very important is that the surface we are working on is a non-scratch surface, so we are able to cut the glass without scratching. Okay. Materials that we're going to need in order to cut glass is turpentine. We use turpentine instead of an oil base that some glass artists use in the back of the glass cutter. It helps for gliding of the glass cutter. It's a small little wheel on the top that basically scores the glass and allows us to break it. I have already marked the area I will be cutting. This is rather important to make sure that we do not go skew. What does help is having a glass ruler. It's padded on the one side to allow the surface of our glass not to scratch. I need to make sure that there's no obstacles in the way when I'm cutting my glass. So I'm taking my ruler, I'm placing it flat down on the glass, on the spectrum glass that I'm working with. I'm then taking my turpentine. I dip my glass cutter into the turpentine, and the first thing I'm going to do is actually I'm just going to glide that turps across the top of the glass. This is just to make sure that the glass is basically lubricated with turpentine. I can then dip my glass cutter in again, and I make sure that my hand is sturdily down on the glass ruler, and I'm able to cut the glass from the tip and score it. You want to hear that sound. When you hear that scratchy sound of the glass, we know that we are cutting the glass or scoring the glass. We then are going to use happy snappers. This is basically what this tool does. It breaks the glass in half. At the top here, you'll see a line. This is normally your top section of the area where you scored the glass. And when pushing it flat, it actually pushes the glass away from each other. So I'm going to make sure that that line I just showed you is in the middle of where I've scored my glass. And I'm going to apply pressure, and it cracks and breaks the piece away. Simple and easy. All right, so we have now cut 3 different colors. I'm putting it like this so you're able to see how the color changes when putting them on top of each other. So what I'm going to do is I'm going to use my solid color as my base color, and then I'm going to apply strips of the blue and the pinky color going horizontally across the light blue. Okay, so I have cut all my strips that I need for one of the pieces. Remember, I will be repeating this 3 times because I want 3 of these glass pieces fused at the end. I'm now going to use my marker, and I'm going to mark out the area because I need to drill with a diamond tip drill into the glass so that I'm able to put through some cables or some ribbon or something like that to be able to tie that my mobile can hang. So I've laid this out, and I'm just going to mark the area between where I can drill that it won't interfere with my design. Okay, I have now marked my area out. Closing that. So I'll mark this out now, and I'm going to make the actual marks where I want the dots. I'm going in by 10 mil for each one. So we have some form of consistency. It is very important when you drill that you do not drill too close to the edge, otherwise there's a possibility that the glass will actually crack. I'm now going to move to the cold shop area, and we're going to be drilling. Welcome. This is the cold shop area, and this is where we do everything that's related with cold working of the glass. I'm going to explain to you how to drill. First of all, what's very important is our PPE. So we need to ensure that we have clear spectacles to cover and protect our eyes, as well as some form of ear protection for our ears. Just going through the basics of the drill bit. What it is important, I'm just going to put my spectacles aside. What's important is that we adjust our drill press according to the height that we need for our drill. Okay, and we are going to work with this arm, and we are going to bring it down slowly onto our glass. Remember, what is very important is that when we are drilling, that we drill a little bit at a time, and we need to lift it up slightly to make sure, and I'll show you now, to make sure that our water is constantly coming out of the drill bit. This drill bit is a habit diamond tip drill bit. The water basically stops our glass from getting hot, and it keeps it cool whilst drilling. And I'm going to show you now the on and off button. So what's important is that when we're switching it on, it's the green button, and when we switch off, it's the red button. Before switching on, ensure that your water is running out of your drill bit, and then you will switch on. And that the red button is your off button, and that you switch your water off afterwards. just finished at the cold shop area and I have drilled my holes into my glass piece. Remember, I'll be doing this 3 times because I need 3 of these pieces. I'm then going to place these other colored areas on top so I can show you an indication of what it would look like. Okay, so what I'm going to do now, I'm going to clean my glass, get it ready. It's very important that our glass is clean before we put it into the kiln. And then I'm going to show you all how to prep a kiln shelf, followed by prepping our kiln, placing our glass in, and getting it ready to be fired. And then after that, I'll go through a basic kiln program with regards to spectrum glass. As you need to remember, different types of glass will do different things at different temperatures because they start becoming molten at different temperatures. Okay, I am now going to show you the prepping of the kiln shelf. As you can see, this kiln shelf is actually dirty, so we need to scrape the old plaster off the kiln shelf. Which is basically a crystal layer that forms, like a milky crystal layer that forms on top of our glass. In order to prime our kiln shelf, what we need is a kiln brush. It's a soft bristle brush that we can use, a little bit of water, and a good quality plaster of Paris. Inside the bucket of water. Remember, we do not put a lot of plaster. We're not making a mold, so we're not looking for that reaction to happen where the plaster goes half. It's basically making a watery solution of plaster. I then dip my brush at the bottom. It's important to place the brush every time right down to the bottom, so you pick up the plaster every single time. I now place it on the edge just to take some of the water off, and we're going to coat our kiln. We always go the same direction in one way. First, applying normally 2 to 3 layers, depending on how thick our plaster mixture is in our bucket. This coats our kiln shelf so that our glass does not stick to the kiln shelf. So it forms a release agent. I've coated the one direction, then we coat the other direction. The reason for this is because glass picks up any detail, and by going in a cross section every time, I minimize brush marks on my glass. One can obviously also apply the plaster in a dry solution. This will create a textured background for our glass. every time I am picking up the plaster from the bottom of my bucket and I am wiping it on in one smooth direction. Okay, it's very important after you've worked with your plaster, do not throw this down the drain as it will block your drains. Throw it into a dustbin or allow it to dry in the bucket and remove it later. It's also important to immediately clean your brush of water. Make sure all your plaster is out, otherwise you would need to throw this away as it will go hard. What is important now, I've cleaned my brush, my bucket. I need my kiln shelf to dry. I need to make sure that there's no water on this kiln shelf when I fire my glass on top. Water can also cause devitrification or devitt on our glass. So it's normally important that you do this process the day before, so you give your time to dry out for a 24-hour period. I'm now going to explain to you the whole prepping of inside your kiln. This is our kiln. We specifically use this only for glass. It's very important that if you are a ceramist artist, that you do not use the same kiln really for glass because of the dust that comes with a ceramic kiln. So we try to keep them separate, so this we only use for glass. You'll see the kiln consists of fire bricks at the bottom, and it has elements on the side as well as in the top. This is our kiln program, our controller, where we put in our program that we want our glass and what we want it to basically do in the firing. This over here is a bunghole. This is to allow oxygen, or an area where someone can look inside when the kiln is hot and see what the glass is doing. When prepping our kiln, what we need to do first of all is make sure that our kiln is clean. And what I mean by making sure our kiln is clean is getting a vacuum cleaner, and we need to come and suck up any of the dust particles normally caused by the plaster that we've used. Also important to go lightly, not on top of the elements, but lightly run your vacuum cleaner over the top of the elements. All this preparation is very important, as all these small steps stop any form of devitt that is possible to occur on your glass. Explain to you now how our controller works, and we are going to fuse spectrum glass together. What is important in our controller is that we put in a program, and our program changes according to what we need to, how we need to manipulate our glass with heat. If you just look at the top here, you'll see a thermometer icon and a clock icon. These are important with any controller because it kind of explains to you what process you are busy with in your controller, within your program. This here is reading the temperature at the moment inside the kiln. Okay, so if we go with the arrows, it will go through the program. So you see we're going up all the way, and then we're going to bring our glass down. So these arrows here will bring you into the different sections of our program. So program for the beginning, this is a delay. So you'll see it's a time that is highlighted at the moment or on. So this is indicating that it's only time that is being processed here. And the up and down arrows are where we can change what we want that dot to do basically. So at the moment, I can put a delay in for my program to only come on later. So that's reading 6 seconds. So if I want my program to only start in 6 seconds, that's what I'm indicating here. If I go up, that's obviously now 12 seconds. So you see that's hours, minutes, and seconds. Okay, but we don't need a delay because we're going to start our program immediately. So I'm going to keep it on 0. The next dot indicates a time with a thermometer icon. They are both highlighted. So this is basically telling us now that how many degrees an hour to get to our next top temperature. So I wanted to go 200 degrees an hour up to 580 degrees. And you'll see that's the temperature I wanted to reach. So only the thermometer is reading at the moment. I can change these numbers with this up and down arrow here. Okay, then our next step, you'll see the dot is only indicating time. So this is now showing it's a soaking point. So I want my glass to soak for 10 minutes in the program at 580. Between 0 and 580, our glass is the most fragile. So we actually want our glass to go up slowly until it gets to 580, and I'm holding it for 10 minutes. Our glass is not that thick. So 10 minutes is allowing that, or ensuring that all our glass is the same temperature of 580 degrees before taking it up to its top temperature. Then I'm gonna make my program go full. So you'll see it's time and our thermometer reading. So we are saying we wanted to go how many degrees an hour. So full is basically indicating that I wanted to go as fast as possible up to my top temperature, which is 780 degrees. Just to go back, full, to get to that temperature, you would actually have to push the arrow, keep pushing it up until it reads full. Okay, so then our top temperature for our fuse that we are doing, and we're doing, you can say it's not quite a tack fuse and it's not a full fuse with the spectrum. It's a bit of an in-betweener, so the glass is nice and soft on the edges, and you'll see by the photographs in the end. Okay, so we're holding it at we're taking it to the top temperature of 780. Again, it's our thermometer that is just showing. So we are just talking about temperature within the program. Our next one is now time again. So it is a soak period. This soak period is quite important because we want to hold it at 780 degrees and ensure that our glass all fuses together at that temperature. You can also hold it for longer. It will make it fuse more together, or you can have it less, which will make it a more of a tack fuse, depending on your finished product that you want with your glass. You'll see again that it is the time and temperature that is highlighted. So therefore, we are soaking. Our next section going down is quite important. This is called a crash score. One can also do this manually, but I'm going to explain to you how to do it in our controller, in our program. So we are now telling our program to go full again. But now we're not wanting to go full up, we wanted to go full down. So again, time and temperature, we wanted to lose as much heat as possible. Otherwise, this is where devitrification is caused, or for instance, if we are busy with a dropout, we want to capture that moment that we see in the kiln and freeze it. So we need to bring a kiln's temperature down to where it doesn't move anymore, where we're going to bring it down to 580 degrees Celsius. This 580 degrees Celsius, you can see we are talking about just the temperature. So if I go back one, I am annealing in this section, and I want my glass to go down full, down to 580 degrees. At 580 degrees, it's the same as going up now. Now my glass starts to become fragile. So I need to hold it, time and temperature. I need to hold it there for 20 minutes to ensure that all the layers of my glass is equal temperature before bringing it down slowly. This is important because if you're working with thicker glass, you would hold it at this for a longer temperature in this soak period. We are holding for 20 minutes. We are now going to anneal the glass. So we are bringing the glass down at a slow temperature and ensuring that the glass has no stress. So here we are now going to bring the glass down again, time and temperature. So 100 degrees an hour down to whatever the room temperature. Ours is 30 degrees, 60 degrees, you can still open the kiln a little bit. You won't be able to take it out the kiln, but 30 degrees is a nice temperature. Room temperature, when you can touch your glass, is when you may remove it from the kiln. Okay, so just to go quickly through the program again. So you'll see that we're going up 200 degrees an hour, up to 580 degrees. We're holding it for 10 minutes. We are then taking it up as fast as possible, up to 780 degrees, which is our top temperature. We are then soaking it for 15 minutes, and then we are crash cooling it down full, as fast as possible, down to 580 degrees. And then we are going to soak it there for 20 minutes to ensure our glass is all the same temperature. We are then going to anneal our glass by bringing it down 100 degrees an hour down to 30 degrees. And then we'll push start, and once the green button comes, the green light comes on, it says processing, you'll see that our program is in. Let me just quickly go through. And you'll see that we are in, our temperature is rising. As you can see, our glass has fused lovely together here, and we're very happy with the process. And now what we are going to do is we're going to take these pieces out and we're going to slump them. So that will be our next process. So we're going to manipulate the shape. So it won't be straight anymore. I'm going to curve the glass. I'm now going to explain to you the slumping process. This is the mold I have chosen. It's a ceramic mold. You can see it's hollow on the inside. It has been bisque fired. And I have some water in my bucket, my brush, and the plaster I'll be using to coat the outside of my mold to ensure that my glass does not stick. First things first, we need our PPE. Some paper. Okay, so once this whole area has been coated and I'm happy with it, we normally allow it to dry for 24 hours just to ensure that all the moisture is out of the mold, or you can place it in the sun. Remember again that this leftover plaster gets placed into a bin, don't chuck it down the drain, and that your kiln brush is immediately washed. Otherwise you won't be able to use it again. All right, so now I have my mold is dry and I've placed my spectrum glass over the top of my mold. Ensure that you wash your glass every time after you fire it, and once you've cleaned your glass, that you pick your glass up on the edges. Glass has a memory when it gets fired, and it picks up any detailed fingerprints which may cause divots, etc. at a later stage. What we're going to do now, I'm going to take you through the kiln program that we've used. So we're not having a delay as we immediately starting the program, and we're taking it up to 150 degrees an hour, up to 580. Remember, that is the point where our glass is the most fragile, so we need to take it cautiously up. We're holding it there for 10 minutes to ensure that our glass is all at 580 degrees. We are then taking it up full as fast as possible up to 680. We don't need to take it slowly up there. There's no tension in our glass at the moment, so we can take it up faster. Our glass will stop moving at around 680, which is fine for a slump. And we're going to hold it there for 15 minutes to ensure that our glass takes the shape of our mold that we have chosen. We are then going to crash cool. We're going to allow our kiln to do that. So again, we're going to say full to allow the program to go as fast as possible down to 580 degrees. When we get to 580 degrees, we need to now take it cautiously down. So we're going to anneal our glass and we're going to hold it at 580 first for 20 minutes to ensure that all the glass is at 580. And then we're going to move it down 100 degrees an hour down to our room temperature. Okay, now I'm going to push start on the program and you'll see it starts processing. And the first thing we do is we close the lid. And we allow the lid to be open for the first section of our firing till our kiln gets to 100 degrees to allow if there's any moisture in the actual kiln that it can actually escape out. And then once it's at 100, we close the kiln and we allow it to fire through and we can open it up when it's at room temperature. We have Sarah busy demonstrating for us on how to create a donut bead, which will have details on it like dots or stripes, and she'll be doing a barrel bead as well for us to explain to us how that is done. Also, we'll put in some detail on that as well. This will form as part of our mobile project where we will have the little beads hanging from the kiln form pieces. Busy demonstrating now to us. She has a mandrel in front of us. That's what we create and we use to coat the bead glass onto. And she's showing us here, she's trying to find out if it's a straight piece. As you can see, the one is slightly bent, so that one she will not be using. So she'll put that one aside. And the other rod now of the mandrel, she'll be showing how we coat it with bead coating, bead release, sorry. It's a bead release that we coat the mandrel with. So please ensure that the whole mandrel is coated, otherwise the bead will stick to the mandrel. She's tapping on the side to ensure that there's no air bubbles, and then she will erect it upright to make sure that it is coated evenly throughout by tapping it. This will be placed aside into the mandrel holder so it can dry out and be ready for use for just now. Sarah is busy demonstrating that to us now about switching on of the torch. First of all, before the torch switching on, she'll show us our PPE, which is very important. We need proper glass. Sarah will be showing us first our PPE, which we need to wear, which is glass, special glasses used for beading, which she will place on. Okay, and now she'll be demonstrating to us how to switch the torch on. So the top knob at the top is for gas, the red one, and the bottom one is our oxygen. We always open up the gas first, a little bit, slightly. Remember, when we say open, we are tweaking it just a little bit, and we're using a flint to switch it on, which creates a spark. So at the moment, gas is coming out, and she's going to use that to create a spark to light the flame. A bit more, vigorous, vigorous, vigorous. All right, she has the gas on and you have the orange flame. Now we need the flame to become hotter, so she'll be opening up the oxygen. Again, we're opening it up just slightly, and now we'll play around between the oxygen and gas until we get the right consistency of our flame. We are looking for those short flames at the back, followed by a blue flame to a slight orange, and it needs that slight wave at the end. What we are going to need tool-wise for this project, we are going to need a paddle, graphite paddle, to shape our glass, and she has a tweezers on hand as well. She will now be picking up her mandrel, and she'll be first drying it out to make sure that there's no water anymore on the mandrel. By doing this and knowing when it's ready, it becomes like a bit of a white color, and in that way we know that the mandrel is dry. Once that is done, she will be then picking up her first glass color rod, and she'll be heating that up slowly from the back end in the cooler flame, which is your orange flame, and slowly bringing it in to your warmer flame to the front, which is the blue flame. This needs to be done slowly, as otherwise the glass will crack and it shards off, and it can sometimes hurt you by going into your eyes, etc. Note how she's turning both the mandrel and the glass rod all the time, and this is to ensure that the heat is distributed from all angles. With the glass rod as well, we are heating just the tip, as we are only working with the tip of the glass, which is then wrapped around the mandrel. You can see now how the tip of the bead rod is forming an orange glowing head. This is showing us how the glass is heating up and becoming at a molten state and getting ready to be applied onto the mandrel. If the mandrel is not hot, the glass will not stick to it. Okay, you can see it's starting to get ready to be applied. She's busy forming a ball at the tip of her rod for easy application. She has now turned the glass rod at a vertical state to make it easy to wrap it around the mandrel. One should never force the glass onto the mandrel or pull it. It should just glide and wrap around like soft honey would wrap around a teaspoon. If you pull the glass, you have a tendency to pull the bead release off. You can see here now how she's wrapped around the glass on the mandrel and formed a perfect donut. What she's doing now, she keeps turning it at a constant 360 degrees in one direction away from her. And this, what we're doing now is we're trying to form, the glass will basically contract back on itself and it will create a perfect round ball. She's moved it slightly out of the flame because she's happy with the shape, and she's allowing it to cool slightly. As you can see, the color has changed back to the light blue state of the actual bead. Sarah is now getting ready to make a barrel bead. She's now busy making sure that her mandrel has no moisture in it, and she's picked up her rod, which is a nice turquoise color, and she will now be forming a barrel bead, slowly heating up her glass rod by bringing it into the hotter flame, constantly turning the mandrel and the glass rod, ensuring that all sides are heated. You can now see how the glass rod color at the tip is changing color, and it's starting to make like a cherry at the tip, showing that it is getting warm. It is important that as you see the glass is starting to get warmer, you can see how Sarah is slowly bringing that rod closer into the flame to ensure that it forms a bit more of a molten state to make it easier to apply onto the mandrel. It is also important to constantly turn the rod to keep the glass on center, otherwise the glass will tend to drop to one side due to gravity. You can see the ball at the tip of the glass rod, which is forming and becoming a lovely soft molten state, which will then be wrapped around the mandrel. She has now turned it vertically, getting ready to apply it onto the mandrel. This will be done the same as previously, where she will wrap a donut around the mandrel. She uses the flame to basically cut the glass away from the mandrel and the bead from the rod. She's now turning it, ensuring that it's a perfectly round donut. She's now going to heat the glass rod again to apply another donut right next to that donut, which will then form a barrel bead. Once again, starting from the outer cooler flame, moving in to the hotter flame. Note how she's constantly turning the mandrel that has the donut bead already on it to ensure that it stays center and warm throughout while she's getting the glass rod ready for the next application. You can see now how the glass rod has formed a molten blob of glass at the tip. She's getting it ready now by turning it vertically to wrap it right next to the other donut bead, which will form the barrel bead. The more donuts you apply right next to each other will show how long your barrel bead will become. So if you put 3 donuts next to each other, it will become a longer barrel bead. She's now melting the 2 donut beads together. Glass has a tendency to contract back on itself, so they will join together. She's now opening up the gas to make her flame slightly bigger. You can actually see now how that line is joining together. She will be now creating a third donut, so she's heating up her glass rod again. And at the same time, she's keeping her other two donuts at the back nice and warm. Otherwise, they will crack or go off center. You can see now again how the molten glass is forming like a cherry blob of molten glass at the end of the glass rod. She's turning it vertically upside down, getting ready to apply it onto the mandrel right next to that second donut. This will then create a longer barrel bead. She's applied it around a full 360 and has pulled it slightly away so the flame can cut the glass from the bead. She's now using the flame and keeps turning the mandrel to ensure that the three beads, donut beads, join together to form one barrel bead. It is very important now that you do not turn the mandrel too fast. You need to go slowly to ensure that your heat is distributed at an even temperature throughout the barrel bead, and that you're keeping your mandrel horizontal at all times. So if you do not do that, the bead will tend to move more towards the side that you are holding it because of gravity. So we need to keep it on center by turning constantly away from oneself at a slow pace to ensure that all the donuts join together to form a single barrel bead. You can see now how they've all joined together. She is now getting ready to use the graphite paddle, where she will use to shape her glass bead. She'll work on the edges first, ensuring that they are straight. So she uses the side of the paddle and runs the glass on the edge, ensuring that it makes a proper angle on the barrel bead. Okay, she's now going to use the graphite paddle, and she's rolling it onto the graphite paddle, not hard, a nice consistent, and that creates a nice round barrel bead. It's important to use consistent pressure when rolling it on your graphite paddle to ensure that you do not push your bead off center. One does not need to use much pressure. It's just a light press and rolling of the bead with the mandrel, keeping it horizontal and creating a beautiful barrel bead. She's now working on the edges. You can see she's heating up the one side to ensure that that side is perfect. And we'll continue this process until you are happy with your final shape. Okay, you can see now we are happy with the shape of the barrel bead. So we're slowly going to bring it out the flame to slowly anneal it. So we are cooling the bead down slowly without shocking it. And we're constantly turning the mandrel still at a horizontal to keep it centered. Once the bead has changed shape and we are happy with the desired look, we will then place it into the vermicular pot to allow for further cooling. Hi everyone and welcome. We are now got Sarah busy demonstrating for us how to put a solid stringer. This is part of our mobile design. These will be the beads that hang at the bottom. We need the solid stringer, which will become part of our donut bead, where we're going to learn how to wrap that solid stringer around the bead. Sarah's going to demonstrate now for us, lighting the torch. She's opened up the gas, the red knob at the top, and she's using our, what's that thing called again? Okay, flint. And she's using our flint to switch on the gas where it creates the orange flame. She's now opening up the oxygen on the right hand side to adjust the flame to a lovely, short, consistent, the tip of the flame will have a slight orange tip with a little bit of a flow, and the back of short blue flames at the back. Note that Sarah has her proper PPE on, which is specialized spectacles that we use in the glass beading station. Okay, she's now going to select our color that we'll be using to pull our stringer. The tool we'll need is a tweezer and just our glass rod. She starts always at the back of the flame with heating up the rod. This is to ensure that we heat the rod slowly, otherwise it's going to shatter. And slowly, slowly, as you see the tip of glass heating up, we bring it closer into the flame so we can make molten, like a molten cherry at the ball of the rod. You can see how the color of the rod is starting to change now. It's starting to get that red glow to it. And notice how she's not just heating just the very tip, it's about a centimeter to a centimeter and a half of the front of the tip of the rod. What is important to remember as well here is that all glass rods will heat up differently depending on the color. So you'll find some of the color is much softer and the others are harder. So that is also important to note. Notice how she's turning the ball of molten glass onto itself and turning the rod at a slight 45 to make sure that it collects on the top and does not distort and come out of, if you let it hang down, you're going to lose control of that, basically that molten ball. So you're trying to keep control and build up a molten ball of glass on the top of the rod. And notice that consistent turning, as in any other beading video we have shown, otherwise gravity takes toll and the glass will start dropping down. You can see that ball of glass is getting ready now. Almost ready to be pulled with the tweezer. She's using the tweezer in her right hand and the molten glass is in the left. What is important to note now when she's pulling the glass is that the faster you pull the string of glass, it will make a thinner stringer. So the slower you pull it, the thicker your stringer will become. She's now grabbing the tip of the ball and she's pulling slowly and gently. She's paused a bit there to make sure that we don't pull too quickly and to keep a consistent line for that stringer. She's now going to, once it's taut, she's used the flame now to basically break and burn away that stringer away from the main rod. Okay, there we go, there's her stringer. Notice she's not picking the stringer up with her hands, and that is because it is still hot. She's just fixing up your glass rod so you can use it later on. We don't want this thin little strand at its tip, especially if you're going to be making a bead onto a mandrel. But we're just melting that glass back onto itself to form a glass ball, using the graphite pad at the bottom just to shape it. And as you can see, we are happy with the shape. There we go. All right, that is a solid stringer. Okay, stop. Hi and welcome back. We have Sarah again demonstrating some beading demonstrations to us for our mobile. She's going to be showing us now how to create a twisted stringer. Well, what is required is 2 glass colors that you have chosen for your twist, and a tweezer and a flint to light our torch. She's now going to open up her gas and use the flint to create a spark to ignite the gas. Once we have ignited the gas, she's going to adjust the oxygen and gas flame slightly until she's got her required flame that is needed. Sarah is just heating up the tip to fix the tip of the turquoise rod before we start. Which one are you doing on which one? Which one's going on which one?
I think it's going on.
Okay. All right, you can see what she's going to be doing now. Her turquoise rod is going to remain in a cooler flame towards the back, and her, you can call it a marshmallow pink, I would almost say, is in a warmer flame in front of the turquoise rod. The bluer the flame, the warmer the heat is, and the more orange the flame is, the cooler the heat is. So she wants the pink color to be in a warmer flame, and she will be heating up about 2 centimeters of that front of that tip, because basically what she's going to be doing is taking the turquoise rod, which is going to be of a stiffer consistency, and laying the soft molten pink on top of the turquoise, and then using the flame to cut the one from the other so that you are left with a turquoise rod in your hand with a layer of pink on the tip. You can see how the pink is heating up nicely in the front. Once again, she's using gravity to get her right consistency of her heat and the flow of the tip of the molten glass before laying it on top of the turquoise, which is at a cooler temperature. She's now laying it on top of the turquoise, using the flame to cut the one from the other, and now heating both colors together at the tip. This heating is important because now what's going to happen is she's going to use her tweezer and pinch the top, and she's going to twist it and turn it, which is going to create a binary twisted color of the two glass rods. You can see how it's heated up nicely for us. She's getting ready with the tweezers. Remember that if it's too hot, it's going to twist out of shape. There we go. She's got a nice twist going, and she needs to pull it apart, and it creates a nice twist of the marshmallow pink and the turquoise. Keep turning until the glass becomes stiff, and then you're going to use your flame to cut that section away from your turquoise rod. I keep turning. There we go. And there we go. She has a twisted stringer. Now she needs to remove the color of the pink that has remained on the turquoise rod, otherwise it becomes contaminated for the next person that wants to use just turquoise. So she's going to remove that with the tweezers. She's going to twist it again to get a smaller one, if possible, just to see if we can use that little piece still. There we go. It's a very small little twisted stringer, but it is something at least that one can use later on. But it's important to ensure that the other color is removed from your main solid color that you basically used as a mandrel. There we go. She's removed all that color. She's now going to use the flame to cut this one from the other. There we go. So she's got two stringers out of the process. She's now just fixing the tip up to become a round ball to make it easy for the next person to use. She's going to switch off her torch. Always switch off the oxygen first to get your orange flame, and then the gas after that. She'll then be picking up her mandrel and ensuring that the mandrel is dry, or basically that the bead release is dry on the mandrel. She's picked up her main solid color that she'll be applying to the mandrel to create the main solid donut bead. Notice how she's turning both now and then to create an even heat distribution. She has also started in the cold flame towards the back, and will slowly bring the solid light blue glass rod to the warmer flame in the blue to create more of a molten tip that will be applied to the mandrel to create her donut bead. The mandrel she's also constantly turning. This is also to ensure that it's got an even heat around it. Remember, with beading, one works against gravity. So that is why we constantly turn. Otherwise, our glass rod will start bending the tip, and the glass will just start melting and falling down. You can see how she's creating basically a ball at the tip of the rod of molten glass. And now and then you see how she actually angles her glass rod at a 45-degree angle to make sure that the blob remains on top of the glass rod and doesn't stop blobbing down. The blob on the tip will ensure the amount of glass that you're going to be able to wrap around your mandrel. So it's very important, this procedure, to make sure that you have enough warm molten glass on the tip of your rod before applying it to the mandrel. She's getting ready now. You can see that that tip is starting to build up. And watch the direction of her hand as she moves the glass rod upright when she starts to apply it to the mandrel. It's now ensuring that the tip of the glass is at the bottom, the heated part, and now you can see how she's going to start applying it by wrapping it around the mandrel. So now she's using gravity and she wants it basically to fall onto the mandrel. Try and turn the mandrel at a consistent speed and wrap it around until you have a perfect glass donut. And once again, we are going to use the flame to cut the glass rod from the main donut, and we'll pull the two away. Now she's going to use heat to ensure that the glass pulls back and centers itself around the mandrel. This is a nice process, for instance, if you did go skew slightly with your glass donut, that you can realign it to make sure that it is centered before applying your stringer bead, which are your stringer solid, your glass stringer, sorry. But before she applies the stringer, she needs to make sure her basic shape is perfect. And if the consistency is looking great, she's now taken it out as well into a cooler flame, but we don't want it too warm when applying our solid stringer. She's adjusting the gas to create a smaller flame. The stringer now will heat up quite quickly because it's a much thinner amount of glass. So be careful you do not directly stick it into a warm flame, as it will just shrivel up onto itself. So it like contracts back onto itself. You can see how she's heating up her donut. And she's heating up her stringer. And she's going to wrap it from where the donut starts on the mandrel and finish on the other side. Okay, she's happy with the consistency, but to slowly wrap the stringer around. The other way might be better. Okay, Sarah has her glass donuts in the front now, and you can see how she's cooled it down in the cooler frame towards the tip. She's going to use her solid stringer she created earlier in purple, and she's going to wrap this around her donut. What is important is not to put that stringer too close into a warm heat, as it will shrivel back up onto itself. She's using the flame to keep a heat on the stringer and slowly apply it onto the donut. Slightly more up. Okay, you can see how she's reapplying another section where it broke to make sure that it's a consistent layer right throughout. Okay, she's going to now,
Maybe just show them how.
okay, so you want your stringer to be cold, and you're going to heat the tip, and you're going to join the two together so you can re-pull that stringer to create a solid spiral line. This is quite a difficult procedure to do, You can see she's adjusting her flame now. She wants to ensure now that the stringer, the solid stringer, melts onto the donut. Otherwise, it will chip off. So she wants to make sure it's melted back onto itself to create her beautiful donut. Okay, there we go. You can see it's melted back onto itself. She's now going to take it out to the cooler flame to anneal it to ensure that it doesn't cool too quickly. And once it's changed color, she's now going to slowly take it towards the pot where we have the vermiculite so it can cool down slowly. She's now going to ensure that her flame is switched off correctly by switching oxygen off first, the silver one, which will create the orange flame, and then switching her gas off.